You all know what air pollution is, and you can smell it, you can measure it, and you can also see it. Here you have some pictures of the air pollution in Santiago. I think it's not necessary to give some additional words on these pictures. Now, talking about air pollutants. What air pollutants do we have in the air? There are many, many hundreds and even thousands of different air pollutants, and not all are equally important. But most important air pollutants in all large cities of the world are the fine particles. We call them PM10 and PM2.5, and the nitrogen oxides, NOx, with a special part of the NOx is the NO2, which is a more aggressive part of the nitrogen oxide gases. First, I would like to give some explication on the notions regarding particles. Here you have a diagram which shows the dimension from large to small, from large to small. First point here, this is the hair. This is 1/10 of a millimeter. That corresponds to 100 micrometers. And then we go down and have a dimension of 10 micrometers, which is in the range of the human cells and the pollen. And it goes further down to bacteria and even to viruses. Talking about particles, we often talk about these PM10. This is the fraction that can be inhaled into the human body. And this fraction of PM10, that signifies particles with a diameter of less than 10 micrometers. This can be divided in two sections, in a coarse fraction and in a small fraction. And this small fraction, these are the fine particles, and this is the fraction we call, we name the PM2.5. Furthermore, there is even a very small fraction of ultrafine particles. They are even much lower. But actually, in the PM10, the other fractions are included. But to be more specific on human health effects, it's rather much better to talk about PM2.5 then instead of PM10. What is the concentration of PM2.5 in Santiago? Here I have a diagram of the measurements that have been made in the cities. You see the annual concentrations of PM2.5. Here the values for the years 2000 to 2015. And you see there is firstly a decrease, but in this year there was a very big increase in the PM2.5 concentration because of the poor weather situations you have had in July in this year. However, also the other values, the blue values here, they are very much above the recommended standard, which is recommended by the World Health Organization. This standard recommendation for PM2.5 is 10 microgram, while the measurements they range in the values from 24 to 40 micrograms. For NO2, I also have some measurements in Santiago. Again, here we have the annual means for NO2 for the years 2010 to 2015. Here, the values that are measured in the Parque Origin, they are about in the range of the WHO recommendation. So this is rather a better situation. However, this value of this recommendation of the WHO only reflects the effect of human health. But NO2 has also other adverse effects, and I will come to these effects a little later in my presentation. Now to the health effects. Very famous episode was in 1952 in London, the London smoke. Here in this city there were during some few days very high concentrations of air pollution, sulfur dioxide and black smoke. And in the same time, in these days, there was a very dramatic increase of death in these cities, and the correlation between the death, the additional death, and the air pollution is very obvious. This was this shows that was an increased mortality due to very high air pollution during some few days. This, of course, was an extreme situation. And the question is now, how about the effects of air pollution that is not extremely high? And for this, I have a presentation that is also very famous. This is the so-called 6 city studies made in the USA from 1978 to 93. And the question is, is there an increased mortality due to air pollution? And correlation measurements and correlation were made with many different air pollutants, sulfur dioxide and the nitrogen oxides and particles, and the best correlation was seen between the increased mortality and the particle concentration, and this is very well shown in this correlation, and this means that the most marked effect of increased mortality is in this time, in this study, by fine particles in the air. There is now came out a new study just in this year, in July of this year. It was done by the famous King's College in London on the health impact of air pollution in London City. And the results were also very impressive. There was found that there is increased mortality due to the long time exposure to fine particles and also to the nitrogen oxides. The results of this King studies are really impressive. For the fine particle pollution, there resulted an equivalent of 52,000 life years lost per year. That means not all persons die suddenly because of air pollution, but there is an effect on the life expectancy, and for some people there is a reduction of maybe some weeks, some months, or even some years. And so all these small amounts have been added for the whole population, which came out then with this number of life years lost, and this is the life years lost per year, and which would be equivalent to a number of about 3,500 premature deaths in a year. A similar effect has been shown for the nitrogen dioxide situation. Here we have even 88,000 life years lost per year, which is an equivalent to 5,800 premature deaths. And the total effect of PM 2.5 and NO2 is just to add these figures correspondingly. So there is really something to be discussed. Coming to a conclusion for health effects, it has been seen that there are important health effects by short exposure to very high pollution, but also to long time exposure to relatively low pollution. Important pollutants are fine particle, PM 2.5, nitrogen dioxide, and the London study just showed that the health effects of NO2 are at least as important as the health effects by PM 2.5. So the consequence of this London study, and of other studies of course, is that we have to reduce PM 2.5 and NO2. Coming to the sources of air pollution, there are of course many different sources of emissions. traffic, industry, heating, small installations, trade, agriculture, and more. Heavy-duty diesel engines are, among others, major sources for fine particles, that means for aerosols, and for nitrogen oxides. Going to the fine particles, the question is, where do they come from? There are two totally different origins for fine particles. We have, on one hand, we have primary particles. These are particles that are directly emitted from the sources as particles, for instance, diesel engine particles. But there are also other particles, the secondary particles. These are particles that are not directly emitted as particles, but they are generated in the atmosphere from precursor gases like sulfur dioxide, nitrogen oxides, ammonia, and others. So not only primary particle emissions must be reduced, but also the emission of precursor gases, and one of these precursor gases, you see it here, it is again nitrogen oxide. Here is the composition of aerosols. These were measurements made in Switzerland. On one hand side, you see the urban situation in a residential area, and here in a traffic situation. The pictures, that means the composition of the particles, is rather similar. Of course, according to the position where you make the measurements, there are differences. For instance, you have here the soot emission. This is, of course, lower in the suburban residential area than here in the traffic situation. What is important that we have, besides these particles that come as primary particles in the air, we have many particles with a composition that is sulfate, nitrate, ammonia, and this is an indication that these are not primary particles but secondary particles. These are measurements made in Switzerland, and here I have, as an example, composition of aerosols, measurements made in China, in Beijing, and in Shanghai. The situation is stunningly rather similar to the values in Switzerland. Of course, the percentages are different, but you also have primary particles, and you have also again these nitrates and sulfates and ammonia and chlorides, which are secondary particles. Astonishingly, as I said, the composition is rather similar to the one in Switzerland, and what is interesting that in this study in China, there was not only made an analysis of the composition, but also of the sources. Where do these particles stem from? And here you also have diagrams, the pictures, and I must show especially these two parts. These two, the violet and the brown here, these are secondary particles. That means in Beijing, about 50%, half of the particles are secondary particles. And in Shanghai, it is similar, it's even more secondary particles. It is about 3/3. So the result of this study in China said that the secondary aerosols contribute 30 to 77% of the total PM 2.5 in the air. It is really, I think, a very interesting result. Conclusions for the fine particles. Fine particles, as I said, they consist of primary and of secondary particles. And both kinds of particles, of fine particles, must be reduced. The primary particles are important, of course, that's no doubt, but the secondary particles, they are equally important. So when we discuss about particle emissions in the air, we may not forget the secondary particles, because they have a share of about 50% of all aerosol particles in the ambient air. Emission reduction of diesel engines, diesel buses. We recommend a 3-track approach. First point is that for all buses, good maintenance of the bus engine and if they are equipped with particle filters, of course, also of the particle filters. Very good maintenance is very important, and in addition, it is necessary, of course, to have a periodic and also a random inspection of the vehicles. The second track is for in-use buses. If it is technically and economically feasible, then it is good to make a DPF retrofit in order to reduce the existing pollution. And for new buses, it is very important, we think, that we apply there and we use the best available technology, and that means in order to avoid unnecessary pollution in the future. So you see there are two tracks. One track is to reduce the existing pollution, and the other one is to prevent unnecessary future pollution. What has to be reduced? We must reduce the primary particle emissions because of the direct adverse effects of the primary particles. But we must also reduce the NOx emissions because, first, of the adverse effects, the direct adverse effect of NO2, but NO2 also gives a contribution to the formation of tropospheric ozone, and also for the formation of secondary aerosol. That's reasons which show that it is very important also to reduce the NOx emissions. Now I come to the limit values for Euro 5 and Euro 6 heavy-duty engines with diesel, heavy-duty vehicles with diesel engines. Here you have an overview from Euro 2 to Euro 6 with the dates of entering into force, the test cycle, the limit values for the NOx and the particle mass limit value. And here, in addition, you see for the Euro 6, we have not only a particle mass limit, but also a particle number limit. Comparing Euro 5 and Euro 6 regarding the particle emissions, we see that the particle mass limit value of Euro 5 and Euro 6, they differ very much, and is a factor of 2 to 3 times between Euro 5 and Euro 6. Particle number. Particle number in Euro 5 there is no particle number limit, and Euro 6 has a particle number limit, and this is also a very important point. So the effect of this regulation shows that the emissions, the particle emission of Euro 6 is much lower than of Euro 5. The particle mass limit is lower by a factor 2 to 3. The particle number limit implies the application of DPF, and thus it is even more stringent than the particle mass limit value. Comparing the NOx emissions, here also there is a big difference in the emission limit values. For Euro 5 and Euro 6, you see we come down here from 2.0 to 0.4, factor of 4 to 5 is the emissions of NOx are lower. Another thing is important for Euro 6 here. There is another testing cycle which is more realistic, and if you combine these together, then we also come to the result that the NOx emissions of Euro 5 of Euro 6 are much lower than the NOx emissions of Euro 5. First, because of the limit value, which is 4 to 5 times lower. Then we have a much more realistic testing cycle, and we have a much better reduction of the real-world driving at low exhaust gas temperature, which is very important in city traffic. I do not go further into the detail of the NOx reduction at low temperature. I think this is an item in the next presentation you will see and hear by Mr. Henk Barbe, which he will enter into the technical aspects of Euro 6. Here, just some pictures of Euro 6 buses from different brands, all in use in Europe, and here some pictures of Euro 6 trucks, all in use with no problems. Coming now to the summary. From the environmental point of view, Euro 6 is much better than Euro 5. That's very clear. And what is the reason? We have less primary emission of particles. We have less nitrogen oxide emissions, and this means less NO2, less ozone formation, and less formation of secondary aerosols in the ambient air. And in my final final slide, I come to the conclusion. We know that diesel buses and trucks, for these vehicles, Euro 6 is presently the best available technology solution commercially available at large scale. In Europe, since January 2013, type approval of heavy-duty vehicles must be done according to Euro 6. Euro 5 type approval are not allowed since January 2013. And for the first registration of heavy-duty vehicles in Europe, since January 2014, the registration of new Euro 5 vehicles is forbidden. So the conclusion is that Euro 5 really is an obsolete standard, and it is also an obsolete technology. The final conclusion and recommendation, therefore, is introduce Euro 6 standard as soon as possible. Thank you very much.